Hello students. So today we will be discussing about the topic known as vector analysis. Now, vector analysis is the first unit of your SEC paper, Mathematical Physics. So, what is this SEC paper? It is a skill enhancement course. So, basically the objective is to enhance your skills. Now, in vector analysis, what will you be studying? You will be studying the basic ideas related to vectors and some operations in vectors so that you will be able to solve problems in physics. So today we will be discussing about what is vectors, the vector notations or representations, and the laws related to some vector operations. These will be the three topics of our discussion today in this video. So what is a vector? A vector is a quantity which has both magnitude and direction. Magnitude simply means the length of the line in which it is represented, and direction shows in which direction it is tending to. That is denoted by the arrowhead which is put across the line. So that is a vector. Now, do you remember any of the vector quantities that you have studied in the previous semester? We have studied plenty of vector quantities. To name a few, we have velocity, acceleration, force, etc. How are they different from scalar quantities? Scalar quantities has only magnitude and no direction. So now some examples of scalar quantities will be work, then distance, speed, etc. Okay, now to discuss about the representations, we have like a few types of representation. One is the graphical representation, which simply means the line and the arrow mark. That is the graphical representation. Then we have the symbolic representation or notation. We have the component form, unit vector form, and polar form. You have to know only the graphical, the symbolic, and the component form. Now, symbolic form means that you write an alphabet and put an arrow on top of it. That is a symbolic form. Generally, you represent vectors in such a way that if it is the length of the line, and the line is A to B, then you write vector AB as AB and an arrow on top of it. So it is written like this. A, B, and an arrow on the top. So I hope you understood what is the symbolic or notation form. Then we have the component form where you split the vector into its components. See, any vector which is drawn like this, an arrow and a line, can be split into its x and y components. That is, you can write this because this vector has a distance from the x-axis and a y-axis. So you can tell that what is the measurement of it from the x-axis and y-axis by using the x component. For a vector A, its components can be written as equal to, in the bracket you write ax, comma, ay. So this means ax simply means how much distance is it from the x-axis, and ay means how much distance it is from the y-axis. So I hope you understood what is component form. Then we have the unit vector form. See, any vector has to be written in terms of magnitude and direction to be called a vector. So now, if you have a vector like this, see, this is your I'll just erase all of this. This is your vector. Then we are talking about the unit vector form. This length from this point to this point can be written as its magnitude. Now, to write the direction, always we need a base direction. That base direction is known as the unit vector. It is simply a vector of length 1 unit in any direction. Then we have the polar form, which is not necessary for you to understand. It is writing the vector in terms of r and theta, which you'll be studying in the higher classes. So now, what you should know is the IJK notations. All vectors can be written as AI cap plus BJ cap plus CK cap form, where IJK are the unit vectors in the Cartesian coordinates. So in Cartesian coordinates, the axes are x-axis, x-axis, y-axis, and z-axis. So corresponding to x, we have I cap. Corresponding to y, we have j cap, and corresponding to z, we have k cap as the unit vectors. Okay, now we are going to discuss the types of vectors. In this, there are few things. Actually, all the 12 are important for you in the physics perspective, because once you're reading a textbook, you will find only these terms. Nobody will explain to you what is it. So knowing what is it is very important. For example, I've already discussed what is unit vector. It means a vector of magnitude 1 unit. Again, zero vector will be easy. It will be a vector of magnitude 0 unit. Then we have negative or opposite, which means the direction is opposite. Equal means they'll be in same magnitude and same direction. Position vector talks to us about the position of the vector. Displacement talks about the displacement. Again, we have collinear, coplanar, orthogonal, concurrent. In this, orthogonal is very important. Orthogonal vectors means they are at an angle 90 degrees from each other. It is very important. See, the initial 6 are about each vector's character, but the remaining 6 from 7 to 12 are a comparison between vectors. So it is important that you know the meaning of them. Okay, the next topic is about a very important concept in the vector addition. So adding two vectors has mathematical equations and all, but two laws are very important in this. One is the triangle of vector addition and one is the parallelogram law of vector addition. So triangle law is when one head of the vector meets the other tail of the vector. That is, if the vector is drawn like this. That is, see, this head is meeting the tail of this vector. Then the third vector should be drawn like this, such that this vector will be the sum of this and this. That is the triangle law. In parallelogram law, it is the opposite. The two will start from the same point and go to different direction. Then the third vector will be drawn somewhere like this, such that if these two sides are part of a parallelogram, then this side is part of this side will be its diagonal. Next is about vector addition. You can add two vectors either using these laws or mathematically. If you're adding mathematically, the thing that you should notice is the very important point in vector addition is you can add only the similar components of the same direction. Only vectors of the same direction or the same unit vector components can be added together. You can add only an I cap with an I cap. You cannot add it with a J or K. That is wrong. Similarly, a J with a J and a K with a K. That is how vector addition is done. Okay, now we have direction cosines, which is the cosine of the angle made by the vector with each of the axes. So if the angle is made with the x-axis, it is cos alpha, y-axis is cos beta, and z-axis is cos gamma, where alpha, beta, and gamma are the angles made by the vector with the x, y, z axes. And direction ratios are nothing but the x, y, z component values. We'll move on to the applications of vector addition. So basically, the main application is, or the first application that we should know is in physics, because that is why we are studying it as an SEC here. Now, the next one will be in engineering, then in computer graphics and animation. You might have heard of vectors there also. Then navigation and GPS systems, where we look forward to the, or where directions are very important. Then in fluid dynamics, and there are many more. Try to fill the other applications by commenting. To summarize, we have learned what is vector, its representation, and the main notation, which is IJK notation. Then we learned the laws of vector addition, which is the triangle and parallelogram law. And later we learned the direction, cosines, and ratios, and some of the applications. I hope you understood what we discussed. So thank you and have a nice day. If you have any doubts, kindly leave it in the comment section and suggest important topics that you would like to see as videos. Thank you.